defined them. We learned a new physical quantity, which is volume. We defined it as space occupied by an object. We did some of the SI units of the volume is cubic meters, and liquids are generally expressed in liters. We did some conversions. 1 meter cube is 10 raised to 6 centimeter cube. We know 1 liter is 1000 centimeter cube. Also we know 1 liter is 1000 ml. So we concluded that 1 centimeter cube is equal to 1 ml. We know measuring cylinder and beakers are used to measure volume of liquids. Regular objects, we have certain formulae which we can use and we can find the volume of the same. For irregular objects, we carried out some experiments using a measuring cylinder and we found out the volume by the change in the volume of the liquid wherein the irregular object was immersed in. And then reading of a volume we did by checking the meniscus. Now meniscus is the curved surface on a liquid when it's stationary. Yes, this all we had done in the previous presentation. Now let's define another physical quantity which we've already done in standard 6. Now this physical quantity tells us regarding the surface occupied by the regular shape or regular object. Now can you guess it? Yes, it is called area. Now this area is the surface occupied by an object. It is also termed as surface area for a 3D objects. Now since the surface or a plane surface is two-dimensional, we have the multiple of the unit as 2 times. Now the volume which we did in the previous presentation, it was a 3-dimensional, and so we had the multiple 3 times, that is meter into meter into meter, that is meter cube. So here in area we have the SI unit as square meters or meter square, and we denote it by the symbol of m raised to 2, that is meter square. Now these are some of the units, multiple and submultiple units. Submultiple being millimeter of a side, so for area it is square millimeter, and if the side is centimeter we have the area as square centimeter, and if the multiple unit of kilometer is denoted for the side, the area of the same would be in square kilometers. Now let us go for some little conversions in the units from multiples to submultiples, and let's check what the conversions would go into. Now we know 1 kilometer is 1000 meters, and if we square it for unit of area we need to square it. So we put 1 kilometer square as 1000 meter into 1000 meter. Now this, check the number of zeros. We have 3 plus 3, that is 6 zeros. So we can represent 1 square kilometers as 10 raised to power of 6, that is 10 raised to 6 square meters. Similarly, we know 1 meter is 100 centimeter and 1 square meters would be 100 centimeter into 100 centimeter. Now again check for the zeros. We have 4 zeros, that is 100 and 100. So our result would be 1 square meters is 10 raised to 4 square centimeters. Yes. Now let's do the next one. 1 centimeter we already know is 10 millimeters. Now when we do the square of centimeter, it becomes 10 into 10. So check the number of zeros again here. There are 2 zeros. So 1 square centimeter is 10 square millimeters, or 10 raised to 2 square millimeters. Now there are different other units which we will be using here, and the conversions we need to know. So let us go for those. Now see in the picture I have given 2 different small pictures. One is the smaller one and one is the bigger one. Now the smaller box is known as 1 air, A-R-E, air. Now air means object is measuring 10 meters on either sides, all sides. It's a square. So now over here 1 air, if we go in the terms of meter, we get as 100 meters square, and 1 hectare is 100 airs. So which is nothing but 100 into 100 meters square, which is 10,000 meters square. So let's go for the unit conversion. 1 acre is 10 raised to 2 square meters. 1 hectare is 10 raised to 4 square meters. And what we did in previous slide was 1 square kilometer is 10 raised to 6 square meters. 1 square meter is 10 raised to 4 square centimeters. And 1 square centimeter is 10 raised to 2 square millimeters. We need to remember these conversions for our solving our problems. Now let's go in discussion of area of regular shapes. Now when we need to find the surface area of regular shapes like square, rectangle, triangle, circle, we already have formulae for those. Now for square we already know its side square, which we did in the previous slides. So for a rectangle we have the formulae as length into breadth. For a triangle we have the area formula as half into base into height. And for circle we have, when the radius is given, we have pi r square as is the area formula. Now for a cylinder, if it is a hollow cylinder, we will just count its lateral surface area, wherein 2 pi r becomes the circumference and h becomes the height. But if we have a closed cylinder wherein the two circular portions are also there, then we will have to consider the total surface area, that is 2 pi r square, which is the two circles on top and bottom, and 2 pi r h, which together forms into 2 pi r h plus r. Volume of surface area of a sphere is 4 pi r square. Now these are the area of regular shapes formulae which are given and which we can use to find out the areas of the following given shapes and figures. Now when we don't have a regular shape, the shape is irregular, uneven, what to do in that case? Now if we have a leaf or a saw, we can draw it on a graph paper. We use a graph paper, we draw the outline, and then we do is count the squares within the leaf. Now what do we do here? We don't count the squares which are less than half. We only count the squares which are full, half or more than half. So let's do an experiment. Now here we have taken a leaf, drawn an outline on a graph paper, and I have tick marked those squares which we need to count. See the squares where the leaf portion is there and I haven't put any tick mark. So if we go to count the total number, it turns up to, come on quickly children, count it. The number of tick marks. Yes, they are 27. But directly we will not write 27. First we will count full squares which are 16. Come on, do it. Try me. Am I wrong? Am I right? Check it quickly. Yes, it is full squares are 16. And then half squares or more than half squares, 11. And together we get the answer as 27. So our area of the leaf is 27 square units. Now here we do not have any unit as centimeter or meter for the square boxes given to us. So when such a unit is not given, we take the unit as square units. Now in the figure, we are going to define another quantity using this 2-3 examples. So please concentrate. This figure we have 3 cubes which are of similar size. So if the cubes are of same dimension, we say they are of equal volumes. Now first one is of foam, second one is wood, and third one is lead. Now there is some difference mentioned in the figure. Please observe. Yes, you identified it correct. The difference is in their mass. Foam is 0.03 grams, wood is 0.7 grams, and lead is 11.35 grams. Now, this states that equal volumes of different substances have different mass. So if we go to see, lead is denser than wood, which is again denser than foam. Now yet another example which will help us to define the quantity which we are going to define later. Now let us see the example first. Now in this figure, what do we see? We see a physical balance which is balanced. That means on either side there is same mass. But there is a difference. Yes, you are correct. On one side there are 7 yellow balls and on one side there are 2 yellow balls. Now if we see, total mass of the either side remains the same. But each ball also is of same size, that is same volume. So from this figure, what do we say? That equal mass have different volumes. So we can conclude that blue ball is denser than a yellow ball because 2 balls of blue are weighing equal as 7 balls which are yellow. So give one more example. If we see here in a glass which is filled with water, this one block is floating and now we see the another block is sinking. Now what happens? The block which is floating is lighter and the block which is sinking is heavier. That's we conclude, right? We say heavy it is or it is a lighter one. Now this denseness of a substance, when we describe, we need to focus on 2 quantities which we discussed in the 2 examples ahead in the slide which we did was mass and volume. So let us define a new physical quantity based on the relationship between mass and volume, which is density. So denseness of a substance will which be discussed with the help of density, the physical quantity. Now it is dependent on the 2 physical other quantities which are mass and volume. So we define it as mass of unit volume of a substance. Now let us see the formulae for the same. Now this density is pronounced as rho and written in a particular format, and the density formula is mass upon volume. On the right hand side of the image we see a triangle wherein m is in the top and density and volume is in the bottom. This figure will enable us to remember the formula in a better way and the relationship between the 3 can be defined in a proper way. Now when we say density is mass divided by volume, you see in the figure mass is up, volume is down. So you can identify mass upon volume. Now when we need to find mass, we see density and volume below. That means we have to multiply density into volume. And when we need to figure out what is the volume, you see mass is on the top and density is bottom. So it is mass upon density. Yes, this enables us to remember the formula well. So please do not forget this triangle. This is another example wherein we can state a substance is having higher density or lower density if we just go on for the same volume substance but the mass is different. So this shows if the mass of a substance is greater, definitely the density will be greater. But the volume should remain the same of different substances. Yes. Now SI unit of density when we discuss, we know that SI unit of mass is kilograms and SI unit of volume is cubic meters or meter cube. So our density, we have a formula mass upon volume. So our unit of density in SI system would be kilograms per cubic meter or kilogram per meter cube. And we can have the density measured in all different units in whichever way mass and volume is given to us. Density unit conversion. 1 kilogram per meter cube or 1 kilogram meter raised to minus 3 is equal to, can be written as 1 kilogram upon 1 meter cube. Now 1 kilogram we know is 100 grams and 1 meter cube will be 100 centimeter the whole cube. So now down we get 6 zeros and up we have 3 zeros. Cancelling off 3 zeros from up and down, we are left with just 3 zeros in the denominators, that is 1000. So our conversion becomes as 1 upon 1000 grams per centimeter cube. So our density conversion is 1 kilogram per meter cube is 10 raised to minus 3 grams per centimeter cube, or if we denote it in the other way is 1 grams per centimeter cube is 1000 kilograms per meter cube. Abnormal behavior of water. Now, anomalous expansion of water. What exactly this term means? Anomalous, the term means as abnormal. Now, we have seen in quite cold regions wherein the ice is formed on the top layer of the water and down the water remains in the liquid state, wherein the aquatic life or marine life is found. Now in this place we see the ice which is forming, and above ice we have a negative temperature. The temperature is measured in minus. But down below the life is still existing. That is just possible because of anomalous expansion of water. Now what is basically this property of water, the abnormal property of water? Let us discuss. Now generally solids or any substance, not solids, any substance on heating expands. We have learned that. And expansion means increase in its dimension, that is increase in its volume. So if volume is increased, definitely density will decrease. So in water, when cooling is done, let us define the substance. When cooling is done, density increases because volume decreases. But in case of water, when the water is cooled from 4 degrees Celsius to 0 degrees Celsius, it behaves in a different way. It expands rather than contracting. And when it expands, its volume increases, and since the volume increases, its density decreases. And when the substance is less dense, that substance definitely floats. So we see ice floating on water, and above water, even if the temperature is low, below ice the water temperature just remains till 4 degrees Celsius, which is enough for the aquatic life to survive, which keeps the water in its liquid state. Children, we are done for today. Let's summarize what we did in this video. Area is the surface occupied by an object. We did SI unit of area is square meters. 1 square kilometer is 10 raised to 6 square meters. 1 square meter is 10 raised to 4 square centimeters. And 1 square centimeter is 10 square millimeters. We also did was 1 acre is 10 raised to 2 square meters and 1 hectare is 10 raised to 4 square meters. We also discussed the formula for area of regular surfaces, and area of irregular surface will be found using a graph paper. We did equal volumes of different substances have different mass. Then we did example of equal mass of different substances have different volume. On the basis of these two properties, we defined density as mass per unit volume of a substance. SI unit of volume is kilogram per meter cube. 1 kilogram per meter cube is 1 upon 1000 gram per centimeter cube, and 1 gram per centimeter cube is 1000 kilogram per meter cube. Anomalous behavior of water, that is abnormal property of water we discussed, which expands on cooling from 4 degree to 0 degree Celsius, which enables the life to survive in waters below the ice. Children, thank you. Stay safe, stay home.